Now we are going to take a look at Anglican High Sec 4 Prelim 2021 Paper 2 Question 1. Angles A and B are both obtuse and tangent A plus B equals to 3/4. Without the use of calculators, 1. State the range of angle A plus B. Okay, now let's take a look at the info we have here. Obtuse, okay, which gives you an angle between, so A will be more than 90, less than 180. Same goes to B angle. Well, we know that if you add the minimum value 90, you get 180 to 360, okay, without this information. But let's take a look at this tangent that gives you a positive answer. So we know that this one can lie in one of these quadrants, but because of this information, tangent must be positive. So we already have the answer in this quadrant, okay? So for question number 1, the angle that you will get, the minimum angle since it falls into this quadrant, is from 180 to 270. Okay, so that's question number 1. Question 2, find the value of sine A plus B. Okay, so since we already have tangent here, okay, I'm going to use this one and let's draw a diagram over here. So if you forgot how to draw the triangle, you can see as like a bow tie drawing. So I'm going to draw this way. Now take a look. I'm drawing it like a bow tie, okay? So you know which quadrant that you are using. So I'm going to use this method to help you remember. We need this quadrant, so this triangle. I'm going to place the value here. So tangent, we're going to use opposite, okay? Adjacent. So I'm going to draw this angle here. I'm going to place the value in first, 3 and 4. So 3, okay, and 4 here. After that, I'm going to just put this in red so you know that I'm looking at this. Okay, now this 3 is the y value below the x-axis. So this is a -3. Same goes to this 4, okay? Is x-axis, okay, is on the left-hand side of this, okay? So it's negative, okay? So when you divide a negative, that's how you get a positive over here, all right? So we have tangent value. So question 2, we're going to find sine. Okay? Now, we need the hypotenuse value here, which we can calculate from this diagram. If not, actually, we all know that you will get 5. Anyway, I'm just going to use Pythagoras and write down the answer over here. Okay, so this 5 is this line here. 5. Okay, so let's do this one. We'll have opposite, which is -3, over hypotenuse 5. Okay, then we have done for question number 2. Next, let's take a look at question 3. Given that tangent B equals to -12/5, find the value of cos A. Now, look at what they give you and look at what you need to find. You're given B, tangent B, but you need to find a cos A. Okay, so there are different angles that. So, if you look at the question, we have this one that involves 2 angles, A plus B, okay? And in question part number 2, you also found sine A plus B, okay? So that are 2 values that you can use. So I'm going to choose one. Of course, I will choose this one, okay? Because it's given to me. So in case my number 2 is wrong. So I'm going to use this to start, okay? I'm going to use this, and you can refer to the formula. So I'm going to write down the formula for tangent A plus B. right? So what can we replace? We know this value from here, 3/4. Okay, so tangent A, I don't have. Tangent B, I have here, given in part 3 of the question, is this value. So I'm going to take this and replace it here. I can change it to negative if you like. Next, divided by, so same thing, I do not have tangent A, but I have this value. Okay, so then we can proceed to solve for tangent A. Of course, you can multiply this whole thing to 3, and okay, you can swap the 4 here too, or you can multiply to 3/4. Okay, I'm going to introduce a way to solve this one because I do not like multiple layer of fractions. Okay, so one of the way you can see it as this separated by this plus and minus. These are called one term. Okay, so I'm going to multiply each term with 5. Now let's look at this. I'm not going to touch 3 and 4 over here. I'm just multiply this tangent A with 5. So I get 5 tangent A. Okay, I'm going to deal with this sign first. So plus minus, I put a minus. I multiply this with 5. Okay, the 5 get cancelled, so I get 12. Okay, now take this one. Okay, it's separated by this minus. Okay, this is a term on its own. 1 times 5, you get 5 here. And then I'm going to do the sign first. So this one minus minus, I put a plus here first. Okay, so this whole term are together, they're multiplication. Okay, they're one whole term together. So I multiply 5. This 5 is gone. I have 12 here. I put 12 first, okay? And then I'll put tangent A. Okay, so I'm getting rid of this fraction. But of course, you want to do it in fraction, go ahead. But this is what I usually like to do. Okay, so in other words, why I can do this way is because I'm actually purely multiplying 5/5. Okay, I did not change the value of this fraction. I'm just multiplying 5 in to this term, and downwards too. Okay, you have to see this whole thing as a term. Okay, I'm going to erase this. And let's focus on solving this tangent A. Okay, so I would like to multiply this denominator to the 3 and 4 to here. Okay, I'm just going to write it again. Okay, expansion. Okay, then moving tangent one side. Negative 48 minus 15. You list it to tangent A equals to negative 63/16. Okay, now remember this is not what you want. You need cos A. Okay, so we're going to draw another triangle here. Okay, so now we know that A is obtuse. Okay, I'm going to use obtuse angle, which is this triangle. Right, I'm going to place this value. I label this angle as A. I'm going to label opposite as 63, adjacent as 16. Okay, I'm going to place, because this is negative, I place negative here. Let's find the hypotenuse here. So 63 squared plus, you want to ignore this also can because you're squaring it, then square the whole thing. You get 65 at this position here. Okay, so you get one nice triangle. Then let's grab cos A. So we get adjacent and over this hypotenuse. Okay, then we are done with question number 3.